You know that feeling, right? When your coding projects just seem to be fighting your own computer, like different operating systems causing chaos, libraries just refusing to get along.
Oh, yeah. Tools acting like they're from totally different planets.
hmm
That whole setup nightmare feeling, it's pretty common.
It really sucks the fun out of building things sometimes.
It definitely can. Getting bogged down in configuration before you even write a line of code.
Okay, so today we're diving into something that can hopefully bring some peace to all that.
Hmm.
Development containers. Think of it like a totally self-contained little digital world for each project.
Exactly. Inside that world, you've got your code, the specific tools you need, the exact versions of libraries all living together happily, and it's completely sealed off from the rest of your system.
So it guarantees that consistent environment. Yeah, doesn't matter if I'm on Windows and you're on a Mac.
Precisely.
Ugh.
Or Linux. And it doesn't care what other random stuff you've got installed globally. Consistency is key.
And the big win for you, the listener, is this can save just a massive amount of time. And frustration, obviously.
Absolutely. No more hours lost chasing down those works on my machine bugs.
It's like getting a fresh, clean slate for every single project. You can experiment without worrying you'll break your main setup.
And collaboration becomes so much smoother. Imagine onboarding a new team member and they're coding productively in like minutes instead of days fighting with setup.
That's the dream. Consistent container environments making teamwork actually work.
It really changes the dynamic. Everyone's on the exact same page, environment-wise, from day one.
So our mission for this deep dive is to walk through how you actually get started with these dev containers, specifically inside VS Code.
Right. We're looking at a source, basically a recording, of someone taking a simple Flask web app and containerizing it step by step.
So you'll see the process, what files get created, what the key parts are.
Yeah, it's a practical, hands-on kind of look.
Okay, so we keep saying development containers. Let's break that down a bit more. At their core, what are we really talking about?
So the main idea, really, is isolation. A dev container bundles everything. A specific project needs the right Python version, specific libraries, system tools, whatever it is, into a container.
Mm-hmm.
And that container runs in its own little world, totally separate from your main computer's operating system and software. It's kind of like having a dedicated mini computer just for that one project.
Gotcha. So instead of my project using, say, whatever Python I happen to have installed everywhere, it gets its own private version inside the container.
Exactly. Each project gets its own little ecosystem, like you said, a self-contained bubble.
Okay.
It has everything it needs, and nothing outside messes with it, and it doesn't mess with anything outside.
That bubble analogy works well.
Yeah. And that isolation, as we touched on, gives you some really big advantages. You totally avoid those awful version conflicts, where updating something for Project A breaks Project B.
Right. Been there.
And you get freedom. Freedom to try out new tools, different library versions, without any risk to your main setup. And crucially, that consistent environment for the whole team.
Makes perfect sense. Okay, so let's say you're convinced. How do you actually start this process in VS Code for a project?
It's actually designed to be pretty easy. You open the command palette in VS Code, usually Ctrl plus Shift plus P or CMD plus Shift plus P on a Mac.
Okay.
Then you just start typing, search for dev containers, add dev container configuration files. Pick that one.
And that tells VS Code, hey, I want to set this project up with a container.
Yep, you're basically opting in, adding the necessary setup files to your current project workspace.
All right, so you do that, and then what happens? It asks about an image or a template. What's that about?
Right, the image. Think of the image as the foundation for your container. It's like a mini operating system snapshot that already has certain things installed.
Like a blueprint?
Exactly. A blueprint or a recipe is a great way to think about it. It defines what the environment inside the container looks like. The container itself is the actual running instance, the building made from the blueprint.
And during setup, you pick one of these blueprints, these templates. The example used a Python 3 one, what does that give you?
A basic Python 3 template usually gives you a fairly lightweight Linux environment with, well, Python 3 installed and ready. But the cool part is the variety.
Oh.
Yeah, you can find templates with Python and data science stuff like Anaconda or maybe Python plus a PostgreSQL database server already set up. Lots of options.
Ah, so you can pick a starting point that's already pretty close to what your project needs. Is there a catch? Like bigger images take longer to download?
That's the trade-off, yeah. A more feature-packed image means more tools are ready immediately, which is great, but it'll likely be a larger download initially.
Versus a simply one.
Right, a bare-bones Python 3 image will be smaller, download faster, but then You'll need to install any extra tools or libraries yourself inside the container later.
Okay, choices. So you choose your base image, then it asks for a specific version, like Python 3.12 versus 3.11, and maybe even different Linux variants like Bullseye or Bookworm. Sounds granular.
It gives you good control. You can lock down the exact versions you need. And yeah, Bullseye, Bookworm, those are just different releases of Debian Linux, the underlying OS for many images. They have slightly different sets of system packages.
So you can fine-tune the base OS too, and I guess some are lighter or heavier?
Generally, yeah. Lighter usually means fewer pre-installed tools, faster download. Heavier means more included, potentially slower initial download, but maybe quicker setup overall.
After the image and version, the demo mentioned optional features. What's that about?
Those are just extra bits of software VS Code can easily add during the setup. Common developer tools, basically.
Like,
Like a rugut, maybe, for downloading files from the command line. It's just the convenience. And the key thing is you don't have to pick them then. You can always add things later by editing the configuration.
okay, like a little optional extras menu. So you make these choices, and boom, VS Code creates a .dev container folder, and inside that, a devcontainer.json file. That folder seems important.
It's critical. VS Code specifically looks for that .dev container folder. That's the signal that says this project knows about dev containers,
Mm.
and the devcontainer.json file inside. That's the master config.
The rear blueprint.
Yep, it tells VS Code and Docker everything they need to know to build and run your specific container environment.
And a key part of that file is the image property, pointing to the Docker image we just picked.
That's right. It specifies the base blueprint. And like the walkthrough showed, you're not locked in forever. You can change that image later if you need to.
Or even use your own custom Docker file.
Exactly. You can skip the pre-built images and point to a Docker file for total control over the build process. That's maybe a bit more advanced for starting out.
Okay, so the config file is there. How do you actually get VS Code to, run the project inside the container?
VS Code is pretty smart about it. Once it sees that devcontainer.json, it usually pops up a little notification asking if you want to reopen the project in the container.
Ah, convenient.
Very. If you miss that or close it, no problem. You can click the little Remote Explorer icon, usually down in the bottom left corner, looks like a screen with arrows, or just open the command palette again and search for Reopen in Container.
Got it. And once you do that, how do you know you're actually inside?
Few visual clues.
Hmm.
The VS Code window title bar will usually change. It'll say something like Dev Container,
Yeah.
followed by your project or configuration name.
Okay.
And the status bar at the bottom often turns a different color, typically blue, and indicates the remote connection. But the most definitive check, like in the demo, open the built-in terminal.
And see a Linux prompt if it's a Linux image.
Exactly. If your host is Windows or Mac,
Yeah.
and suddenly you're seeing a Linux file system structure, bin, et cetera,
Mm-hmm.
when you type LC, you know you're inside the container's separate OS.
Right, that's a clear sign. Okay, what about web apps? If my Flask app is running inside the container, how do I access it in my browser on my main machine? It's not directly on my local network anymore, is it?
Good question. That's where port forwarding comes in. VS Code is really clever here. It often automatically detects processes listening on ports inside the container.
Oh, really?
Yeah. So in the Flask example, it was running on port 5123 inside. VS Code saw that and automatically mapped it. So you could just go to localhost.5123 in your regular browser on your host machine, and it just worked.
That's pretty slick. Does it always work automatically?
Usually for common web ports, but maybe not always, or maybe you want to be more explicit. That's where the config file comes in again.
The devcontainer.json?
Yep. There's a forward ports property. It's usually an array, a list, where you can specifically tell VS Code which ports from inside the container you want to be accessible on your host machine.
So you could add 5123 to that list, just to be sure.
Exactly. The example showed it commented out initially, but you can uncomment it or add ports there. Just remember, if you change devcontainer.json,
You have to rebuild the container.
right, VS Code will usually prompt you
Yeah.
saying the configuration changed and asking if you want to rebuild so the changes take effect.
Okay, that makes sense. Tell VS Code which doors to open between the container and your machine. The demo also mentioned Docker Desktop briefly. How does Docker itself fit in?
Yeah, so Docker's the underlying container technology making all this possible. Docker Desktop is just a handy tool, especially if you're on Windows or Mac, that gives you a GUI to see what's going on.
Like seeing the images you've downloaded.
Exactly. You can see the base image your dev container is built from, and you'll see the actual running container instance that VS Code launched.
Okay.
And one really important concept they showed is volume mounting. your project files, the code on your actual computer.
Yeah.
They aren't copied into the container image usually. Instead, Docker cleverly mounts or links your project folder from your host machine directly into a specific location inside the container, typically workspace your project folder name.
Wait, so they're live synced. If I edit a file in VS Code inside the container?
It's instantly changed on your host machine's file system, and vice versa. Edit it outside, it's updated inside, it's seamless.
Wow, okay. That's way better than copying files back and forth.
Oh, absolutely essential for development, and you can configure other folders to be mounted too, if needed.
That's really efficient. Now, something else that sounded super useful was container-specific VS Code extensions. How does that work?
Yeah, this is a great feature. It helps keep your main VS Code installation really clean. In the devcontainer.json, there's an extensions property.
Okay.
It's just a list where you put the unique IDs of the VS Code extensions you want installed only when you're working inside this specific container.
So the example added Python, Jupyter, and rough extensions there. When you open that project in the container, VS Code automatically installs just those three inside it.
Precisely. They won't clutter up your global VS Code install if you don't need them for other projects. When the container builds or rebuilds, VS Code checks that list to make sure those extensions are installed inside the container's isolated VS Code server instance.
That is brilliant. Project-specific tools without messing up your main setup. Love it. What about that post create command thing? What does that do?
Post create command. Right. So that lets you specify one or more shell commands that should run automatically after the container is built and started up for the first time, or after a rebuild.
Like setup scripts.
Exactly. Perfect for automating things you'd otherwise have to do manually every time you create the container, like installing your project's dependencies.
The example used it to run pip install UV, installing a package manager.
Yep. You could use it to run pip install -r requirements.txt or npm install or whatever your project needs to get set up initially. It just runs those commands in the container's terminal once it's ready.
Super handy for automation. It really feels like this devcontainer.json file is the control center for everything. The demo suggested exploring the schema more. What other kinds of things can you tweak in there?
Oh, there's quite a bit. We covered the main ones. But yeah, you can get more advanced. You can mount additional volumes beyond just your project folder. You can set container-specific VS Code settings that only apply when you're in that container.
Settings, like editor preferences?
Yeah, maybe you want different formatting settings or theme just for one project.
Yeah.
You can define lifecycle scripts too, commands to run maybe before shutdown, not just after creation. It's pretty flexible.
What about environment variables, like API keys or database URLs? How do those get into the container securely?
Good point. There's a remote env property in devcontainer.json. You can define environment variables there that will be set inside the container when it runs. It's a good way to ensure your application gets the configuration it needs consistently, without relying on variables set on the host machine, which might differ between developers.
Consistency again. And can you control resources, like tell Docker how much memory the container can use?
You can. There are properties, I think under runargs or similar, where you can specify resource limits like memory caps. VS Code passes these requests to Docker when starting the container.
Wow, okay. Lots of control. Lastly, the demo mentioned moving beyond the pre-built images and using your own Docker file. When would you need to do that?
Generally, you'd reach for a custom Docker file when the pre-built images don't quite cut it. Maybe you need very specific system libraries installed or custom tools compiled or a particular setup that none of the standard templates offer.
Some more complex needs.
Right. Instead of the image property in devcontainer.json, you'd use the Docker file property and point it to your custom Docker file in your project. That gives you like total control over building the base image from scratch, installing exactly what you need at the OS level.
Makes sense. Start with the templates, they cover a lot, but for really custom stuff, the Docker file is there. Okay, let's try and wrap this up. What's the big takeaway from this deep dive on VS Code dev containers?
I think the main message is that getting started with a basic dev container in VS Code is actually surprisingly straightforward. It really boils down to adding that .dev container folder and configuring the devcontainer.json file inside it. That file is your environment blueprint.
And the payoff is pretty huge, right? Consistent environments, no more dependency hell, easier teamwork.
Cleaner host system, isolated experiments, yeah, all those benefits. It tackles a lot of those classic developer frustrations head on.
Absolutely. Okay, so here's something for you, the listener, to chew on. Think back to a project, maybe recently or a while ago, where you or your team just burned hours fighting with setup problems. Different OS issues, library conflicts, works on my machine, we've all been there. How might using development containers have changed that whole experience? Could it have saved that time, that frustration? Really consider how this approach could smooth out your workflow now and for future projects.
It prompts you to think of your dev environment less as this fragile thing you set up once and pray it doesn't break, and more like infrastructure as code. Defined, shareable, repeatable.
Yeah, well put. And if you want to learn more and really dig into the details,
Definitely check out the official VS Code Dev Containers documentation. It's really comprehensive, covers all the advanced options that we didn't get to.
and just try it out. Pick a small project, add the dev container files, and see how it feels. Experimentation is key.
Couldn't agree more. Give it a shot.